I'm Ken Hamilton with Biominerals Technologies. We're looking at compost and all the benefits we can receive from using compost in our soils as a soil amendment and a way to revitalize the life in our soils. Microbiology is the foundation to a healthy production system. The soil biology control the chemical, which is the mineral. They also control the physical, which is soil structure. And they also control the biological properties of all soils. Every living plant that functions in these soils needs this triangle of chemistry, physiological structure, and biology to grow, reproduce, and produce nutrition. The soil food web is crucial for a healthy, productive soil. We have to have the different trophic levels of all the microorganisms groups functioning in not only the decomposition of the plant, but the control of pathogen, along with the nutrient production that comes naturally. We have the organic matter, which is from decomposing plants and animals. We get into the living organisms such as bacteria and fungi, which are your main decomposers. And then we get into the predatory type organisms in your higher levels that are your protozoa, your nematode, your shredders, your micro and macro orthopods. These all have an interplay relationship in a healthy soil system. They all must be there for your soils to be functioning. Many farmers and producers are told that nitrogen is the most important mineral element in our fertility program, but it's not. Actually, the most important component of plant growth is CO2, or carbon dioxide. As you look at plant growth and structure over time, a plant may emerge with 10 carbons to 1 nitrogen. As it goes through its growth or vegetation stages, that carbon increases up to 20 to 1, 30 to 1, and even 40 to 1. By the time these plants start to get into reproduction and maturity, we're reaching 50 to 1, 70 to 1, even 100 to 1 carbons to 1 nitrogen. This means that we are accumulating carbon dioxide at 10, 20, 30, 50, even 100 or more times at the rate that we're accumulating nitrogen. When we look at dead senescent plant growth, it has carbon-nitrogen ratio of 100, 250, 400, and more carbons to 1 nitrogen. And so it really is the carbon dioxide production that pushes plant growth. Yes, nitrogen, phos, potassium are all necessary, but they are not the driving forces behind plant production and plant biomass. Carbon dioxide is more important to high yield potential than nitrogen or any mineral element. When we look at plant dry matter weight, let's examine the components within that plant. Carbon occupies 45% of the plant's dry matter weight. Oxygen, another 45% of the plant's dry matter weight. Hydrogen, 6, and nitrogen, on average, about 1.5. When you look at this, just carbon dioxide is responsible for at least 90% of the total plant's dry matter weight. Your other elements, such as magnesium, potassium, calcium, phosphate, sulfur, comprise about 2%. But the main structure within our plant is CO2, carbon dioxide, produced by microbiology. Soil microorganisms in higher plants is an 80-year compilation of research that is, in essence, the definitive Bible on soil microorganism and plant function. In this research, it is replete over and over in specifying that the most important component of the soil atmosphere is carbon dioxide, the final decomposition product of organic matter. The intensity of the biochemical processes taking place in the soil can be judged by the amount of carbon dioxide released. The formation of carbon dioxide depends to a large degree on that microbial metabolism Everything that favors the growth of microorganisms increases the generation of CO2, carbon dioxide. Having the right balance of microorganisms under the plants and the crops that we grow is absolutely crucial. You can't have the proper pH or nutrient transfer in that plant's root system without the right microorganisms being present and functional. The balance of biology is absolutely critical when we look at our agricultural and our farming soils. Proper plant growth requires the appropriate balance of bacteria and fungi as per the species or cultivar of that plant. For example, weeds prefer far more bacteria than they do fungi. Grasses, in general, 3 bacteria to 1 fungi. Vegetables, for every bacteria, there's almost 1 fungi. However, in our row crops that we're used to growing, the proper balance of bacteria to fungi is a 1-to-1 ratio. When we get into woody plants such as vines, whether they're grapes or blackberries or blueberries or such, the ratio now switches to being fungally dominant, meaning we will have 5 to 10 times more fungi than bacteria. When we get into fruit trees and deciduous trees, decorative type trees, they're as high as 200 fungi to 1 bacteria. In conifers, it's as high as 500 fungi to 1 bacteria. And in the old growth forests and cedars, it's as high as 1,000 fungi to 1 bacteria. It's extremely important to have the right biology with the plant types that we're growing. Without the proper balance of biology, your plants will not have the nutrition that they require. They will not have the proper pH in the soil. They will not have the protection against pathogens, and they won't develop the growth potential and the yield quality that is in that DNA structure or divine blueprint within the plant's potential.